Every single night, we close our eyes and our minds just take off on these wild, completely unpredictable journeys. But why? What is the actual point of this nightly routine? Well, let's find out. We spend roughly a third of our entire lives sleeping. To put that into perspective, if you hit 90 years old, you'll have spent 30 of those years asleep. 30 years. To crack this case together today, we're going to cover four main areas. First, the great sleep mystery. Second, 5 leading theories of dreaming. Third, a look inside the dreaming brain. And finally, the final verdict. Starting right off with part 1, the great sleep mystery. What exactly is the brain up to during all those hours in bed? You know, dreaming isn't just some fringe topic. It is literally one of the most intriguing and widely studied aspects of human biology. Because the brain is so incredibly active when we're supposedly resting, neuroscientists have had to come up with several prominent theories to explain it. The brain isn't just switching off, it's shifting into a completely different gear. Which brings us to part 2, 5 theories of dreaming. Let's rapidly but carefully examine our main theoretical suspects. What's so fascinating here is the sheer variety of explanations we have. We've got a lineup of 5 prominent theories that span from evolutionary biology all the way to modern neurochemistry, right down to classic psychoanalysis. Each one offers a totally distinct motive for our nightly hallucinations. So let's break them down one by one. All right, suspect number 1 is memory consolidation and processing. This is a very widely accepted scientific concept suggesting your brain basically acts as an overnight filing clerk. Dreaming, according to this view, is really just a byproduct of the brain actively deciding what information and experiences to keep from the day and what to just toss straight into the mental trash bin. So, how does this actually play out? Well, step 1, your brain enters rapid eye movement, or REM sleep, which is where the really vivid stuff happens. Step 2, your brain filters the day's data, deciding what to keep and what to discard. And step 3, your conscious mind essentially tries to make sense of these scattered memory traces as they physically move into long-term storage. And boom, that's what we experience as a dream. Theory number 2 is emotional regulation. I absolutely love how researchers refer to this one. They call it overnight therapy. The idea here is that dreams exist specifically to help us process complex, difficult, or even traumatic emotions, but in a totally safe, risk-free environment while we're sleeping. And here's the science on why that therapy actually works. Neurochemical research shows that stress-related chemicals like norepinephrine drop significantly during REM sleep. Because these panic-inducing chemicals are dialed way down, the brain can safely re-experience highly emotional events without triggering a full-blown physical panic attack. The activationist synthesis hypothesis. Proposed by psychiatrists J. Allen Hobson and Robert McCarley back in 1977, this theory is a bit controversial. It argues that dreams have absolutely no inherent psychological meaning whatsoever. They don't see dreams as meaningful therapy, but really just random neurological static. During REM sleep, the lower brainstem fires off totally random electrical bursts. When these random signals travel up and hit the cerebral cortex, which is the higher level part of your brain that is desperately wired to find patterns, the cortex just stitches this random firing into a coherent, even if totally bizarre, narrative. In this view, your brain is just making up a story to explain random electrical noise. Theory number 4 argues that dreaming evolved as a pure survival mechanism. By simulating incredibly stressful scenarios, like being chased by a predator, failing a huge test, or navigating a really complex social dynamic, but doing it safely in a virtual reality state, we're actually practicing. The dream is basically a rehearsal space, getting us ready to react better to real threats and social cues when we're actually awake. Which brings us to part 3, inside the dreaming brain. Now that we know why we might dream, let's investigate how the brain physically pulls this off. Dreaming is driven by very specific, highly orchestrated neurological activity. And the vast majority of this heavy lifting happens during that crucial REM sleep stage. Just look at this massive contrast in brain activity. During REM, the limbic system, specifically your amygdala, the emotional center, is highly active. Meanwhile, the prefrontal cortex, your logic center, goes completely offline. This perfectly explains why you can have a dream where, you're flying a toaster to the moon, and because your logic center is shut down, you don't even question it. The intense emotion is there, but the logic is nowhere to be found. Well, to keep you safe from physically acting out those vivid hallucinations, your brainstem triggers a temporary paralysis called atonia. It basically sends signals to lock down your motor muscles. So, your brain is running a marathon, but your body is medically paralyzed to keep you safe in bed. All right, part 4, the final verdict. We've looked at the theories and the biology, so what does this all actually mean? The final verdict from the scientific community is that dreaming is highly multifactorial. It's likely doing several jobs all at once, balancing our emotions, filing away memories, and maintaining neural connections. This means that even those terrifying nightmares actually serve a highly functional purpose in processing extreme waking stress. And crucially, even if you are someone who never remembers them, research proves that absolutely everyone dreams multiple times a night.